All right, today we're going to move into lesson 9.5, which is on applying trigonometry. So we're going to look at some real world situations involving really angles of elevation and angles of depression, and how we can use that information to solve for an unknown value. And again, it'll be using our trigonometry concepts that we've already been working on. So first of all, to talk a little bit about angles of elevation and depression. An angle of elevation is the angle formed by a horizontal line and the observer's line of sight to an object above that horizontal line. So if you're looking straight forward, that's the horizontal line of the observer would be you looking straight forward. And then if you looked up, the angle created by the horizontal line and the angle you're looking up is that angle of elevation. Angle of depression is when you take your sight line, horizontal sight line, and look down to see an object. Then the angle of elevation is created by that horizontal sideline and the angle that you've looked down. You'll see these here in a minute in some examples, and hopefully that'll help clear that up. The other idea is we are using the concept of indirect measurement here. We're not actually going to go up and directly measure to find an unknown value. We're going to use similar figures and proportions to do that. And when we talk about similar figures, that's what we're talking about in trigonometry are those right triangles, and how the fact that, the ratio of the sine of an angle is the same no matter how large the triangle is or how small it is. The ratio of opposite to hypotenuse for every, let's say, 30-degree angle is always the same no matter how big or small the triangle is. So that's the idea of using similar figures and proportions. All right, so let's look at for the first one here. So we're looking at an angle of elevation problem. It says Ron is flying his drone at the park. He spots the drone at an angle of elevation that he estimates to be about 30 degrees. The remote control tells him that his drone is 102 feet off the ground. If he's 6 feet tall, how far is he from the drone to the nearest foot? All right, so looking at the drawing, AC is his sight line. That's the horizontal line that he's looking out. And then he's looking up at the drone, which is at point B. So that makes this an angle of elevation of 30 degrees. That's where the 30 degrees would be located. Okay. Another thing we need to make note of is he's 6 feet tall. So the drone is 102 feet from the ground. So if we take away the 6 feet he is, point C here is going to be 96 feet. The distance from B to C is 96. We get that by doing 102 minus the 6 foot that Ron is. And then this AB is what we're looking to find. How far is it from him to the drone in a direct line? So that's the hypotenuse of this right triangle, but that's what we're trying to find. So tonight, when you're doing these problems, you won't always be given a drawing. You're going to have to create these drawings and understand by the description how to set this up, which can be a challenge in itself. Okay, now if we use the information we're given here to find x, I would use sine opposite over hypotenuse. So that's sine of 30 equals 96 over x. We would multiply both sides by x to cancel that x out in the denominator over here. That would give us x times the sine of 30 is 96. Solve for x now, divide each side by sine of 30. Okay, and 96 divided by the sine of 30 comes out to be 192 on the nose. So the distance from him to his drone, that's 192 feet. Okay, so that's using our trig, using this concept of angle of elevation, and one of the most important parts is getting this drawing right, obviously. All right, let's look at a angle of depression. This is kind of an odd one here. It talks about this in Idaho here. They have a dog bark park inn. And basically what you're looking at, this dog shaped deal is actually a hotel. Don't ask me why. So anyway, Pedro's at this hotel and he's standing up here at point A. I don't know if you can tell that's him or not, but there he is at point A, and he's looking out his window. So this AB is his sight line. That's the horizontal sight line we're talking about. It then says he looks down and sees here at point C some fire hydrant. Okay, so BAC, that's an angle of depression. Sight line is AB. He looks down to C. There's my angle of depression. Notice the right triangle goes from Pedro to the ground and perpendicular to the ground. And then from D to C is the distance from the hotel's base, if you will, to the fire hydrant. Okay. We're trying to find what's the horizontal distance from Pedro to the hydrant. So this distance of AB, if B is directly above the fire hydrant, this AB is what we're really trying to find, but we're going to understand that AB and DC are going to be the same. All right. So first of all, we understand that AB, since it's a horizontal line that we're looking out, and DC, which is the ground, those two are parallel to each other. So what that does is makes angle BAC and ACD, it makes those two alternate interior angles. So this is going to be 40 degrees. Here's my transversal. AC is the transversal. Parallel lines, the transversal cuts creates these two congruent angles. Okay, so we know that our x, which we're trying to find, is the distance from D to C. We know A to B and D to C, by the way we have it set up, those are going to be the same distance. So I'm going to want to find the length of x. I'm going to work off of my 40-degree angle. So that's opposite is the 30, adjacent is the x. So we're going to use tangent. The tangent of 40 is opposite 30 over adjacent x. Okay, multiply both sides by x so that we can cancel the x out of this denominator. Divide both sides by tangent of 40. And if I go 30 divided by the tangent 40, we get about 35.8 feet. Directions say, though, to the nearest foot. So to the nearest foot, he's 36 feet away. So the distance from A to B and the distance from D to C are both about 36. All right, so that's an angle of depression. All right, the next thing we're going to look at is what happens if we have to do a couple of different angles of elevation or depression. Okay, the toughest part of this problem, I think, is getting this picture set up correctly. So Well is estimating the height of the second floor of the mall. She sights the second floor at an angle of 10 degrees. So if you look over here, this is Well standing here. She's 66 inches tall. Her eyes are right here at point D. And she's saying here's her sight line, which is DB. If she looks up here at the second floor, that's the DA path, then this 10-degree angle of elevation is created. Okay. She then steps forward 50 feet. So she's going from point D to point C. That's 50 feet forward. And she looks up again. So this Y here is the angle of elevation from this point C to the second floor. Okay. She's 5.5 feet from the wall. So C to B is 5.5 feet. Okay. These are all factors we need to know. And she wants to know what is the height here of the second floor. So we got to figure out what X is. Okay. Actually, excuse me. We got to figure out what Y is because she wants to find out what that elevation is from this point C to the second floor. Okay. The fact that she's 66 inches tall has already been accounted for because we're going A to B and B is her sight line. So we don't really have to do anything with this 66. Okay. One thing we need to make sure we understand is we do have two right triangles here. We got triangle ABD, this right triangle, and angle ABC, this right triangle. So we've got two right triangles. What we need to do here is, first of all, we're going to use triangle ABD, and we want to find out what is X. What is the distance of this second floor? That's common to both triangles, if you notice, the X distance. So take ABD and find the value of X. Well, I'm going to go for my 10-degree elevation. So there's my angle I'm going to work with. I know opposite is X, and I know adjacent is this full distance, which is 55.5 feet. All right, so the tangent, opposite X over adjacent, 55.5. Okay, and now I want to solve this for X. So I'm going to multiply both sides by 55.5, and I now know X is 55.5 times the tangent of 40. Now, guys, if we were just looking for the height of the second floor, we'd be done right now because that's the answer. Okay, 55.5 times the tangent of 40. But what we're trying to figure out is this angle of elevation right here, which is y. So what I'm going to do is leave this as is right now. We can estimate that, but we're going to use it exact. So I'm going to leave it like that. What we need to do now is write a second equation that involves this x so that I can compare it to my first. So what I'm going to do is use triangle ABC now to write a second equation that uses y, which is what we're trying to find, this angle y, and x. Okay, so we're going to use triangle ABC. I'm going to work off of angle y. So I'm going to go opposite is x, adjacent is 5.5. So I'm going to go tangent again. Tangent of y is x over 5.5. Solve for x, multiply each side by 5.5. And the tangent of y, or excuse me, x is now equal to 55 times the tangent of y. So what we've done is we've taken the two different triangles and we've written an equation that will allow us to find the value of x, and we did it in terms of the tangent of y here. So the reason we did that is because now we can use substitution. This x is the same number in both problems. So I can say that 5.5 times the tangent of y, which equals x, has got to be equal to 55.5 times the tangent of 40, which is equal to x. Now notice I only have the tangent of y remaining in here. Okay, so I'm going to solve for that. I'm going to divide each side by 5.5 to isolate tangent of y. I get the tangent of y is equal to, and I just left it like this for now, 55.5 times the tangent of 40 divided by 5.5. Now we're trying to find y, so we're trying to find angle y. So what undoes the tangent function? Tangent inverse. So I'm going to take the tangent inverse of the tangent of y, and the tangent inverse of this number, which I'm just going to leave like this. I'm going to put all this in my calculator and take the tangent inverse of this answer. That will tell me that angle y is about 60.6 degrees. So that whole process here we use to figure out the angle y. So this is kind of detailed. It is complex. I mean, if I gave you another one that looked just like this, I think you could mimic this and get it. It's just trying to expand the ideas that we're working on a little bit. If you have one of these tonight, I'm not even sure if you do, take your time, go back and look these notes over again and see if that won't help. Your assignment tonight is on Alex. So there's not a ton of questions that do. Some of the review of trigonometry is there, but mostly it's angles of elevation and depression. Okay, get her done.